Okay, so we're going to be doing coordinate proofs for quadrilaterals. Alright, we can go through the iBook or we can just freestyle like we're going to do. So first we're going to prove a quadrilateral is a trapezoid or isosceles trapezoid. Example 1, we're going to prove at least one pair of opposite sides are parallel. Alright, so we're going to prove or disprove that quadrilateral ABCD defined by these points here is a trapezoid. So I'm going to go ahead and graph this trapezoid. Alright, so negative 3, 3, 1, 5, 4, negative 1, and then 1, negative 5. Alright, connect the points. Alright, so and then also A, B, C, and D. Alright, let's use the slope formula once, and then we'll just count the other side. And let's do the slope for AB. Excuse me. Let's do it for BC. And I can say that x1, y1, x2, y2. Alright, so we'll get negative 1 minus 5 over 4 minus 1, negative 6 over regular 3. It's going to be negative 2. So the slope of BC is 2. For fun, we're going to count the slope of AD. I always like to count the total slope. Go down 8 over 4. Down 8 over 4, negative 2. So BC parallel to AD. The slopes are the same. So that means that this side and this side are parallel. So that means ABCD is a trapezoid. Okay, now we're going to do a kite, alright? For kites, there are a couple ways to prove that as a kite. You can think about which properties you can prove using one of our algebra tools. So we could use slope, distance formula, midpoints formulas, question mark, which one are we going to use? Alright, so we could consider what properties are first introduced to the hierarchy by the kite and how you might use them one of these methods. Alright, so this is what I would just do. Let's just go ahead and plot these points. So we got negative 5, 7, 2, 6, 5, negative 3, and then negative 4, 0. Alright, we could use the distance formula 4 times, which would be a little much. Or we can see, are these perpendicular bisectors? That's another thing we could do. Alright, so we'd be focusing on V. And S. Alright, so we're going to find the midpoint of VS. VS right here, x1, y1, x2, y2. Alright, we plug in the points, we're going to get 2 plus 5. Hold on. Oops. leaving my points wrong. Okay, we're going to get 2 minus 4 over 2, comma, 6 minus 0 over 2, comma, alright, negative 2 over 2, 6 over 2, negative 1 over 3. Alright, sweet. Then we can also find the slope of VS. Let me pick a different color. The slope of VS, y2 minus y1 over x2 minus x1. So, same thing. We're going to just do 0 minus 6 over negative 4 minus 2, negative 6 over negative 6, which is negative 1. Or, excuse me, positive 1. Alright, so as a slope of 1. And then for fun, we're not going to go too berserk. We're just going to count the slope of RS. The slope of RS. We go down a bunch. We go down 10 over 10. So the slope of RS down 10 over 10, which is negative 1. Now it is hard to tell at times, but RS negative 1 is perpendicular to 1. Alright, this is oppy floppy. So these lines are perpendicular. VS is perpendicular to RS. Alright, so you could say since diagonals are perpendicular bisectors, then it is a kite. We'll do one more. Alright. So parallelogram. Alright. We have 4, negative 3, which is A, negative 2, negative 3, which is B. Okay, so this is saying which is it a parallelogram, and we're gonna keep this one super simple. All right, the slope of BA is 0. Think of slope, dude. This is 0 fun. This is 0 fun. That's 0 as well for CD. All right, these lines, these horizontal lines, are clearly parallel, so I can say BA is parallel to CD. And very clearly, we're going up 3 over 1. Or excuse me, 1, 2, 3, 4. Up 4 over 1. Up 4 over 1. Alright. So the slope of CD is 4 over 1. Or excuse me, BC. Slope of DA. 4 over 1. So it means that BC is parallel to DA. Alright. So opposite sides parallel. So it is a parallelogram. parallelogram.